Today I'm going to show you something very cool. We're going to see how we can do advanced document extraction using Gemini, which means we're not only going to get the information that we want from a PDF document, we're also going to get the bounding boxes. So we're going to see where the information is coming from and what the information is. If you like this video, let me know by hitting a like button and subscribing. But now let us get right into it. Alright, so the use case is quite simple and straightforward. We have PDF documents. These contain some information. In this case, I have a basic invoice, and we want to extract some information from this using structured output. So in this case, we could say the recipient and the total, for example. These are two pieces of information that we want to extract from this invoice. And maybe we also have multiple pages, so that would be the same invoice just spread across multiple pages, not in the best formatting as you can see. But again, we have the information here, the total, and we also have the recipient. So the goal of this video today is not just to get the information. That's quite simple. We just do structured output. The goal is to also get a bounding box around the information. So for example, here around beta industries and down here around total to understand where the information is coming from so we can double check. Now, the cool thing is that we can do that automatically with Gemini just by providing the respective fields for the information for the bounding boxes and for the pages in our structured output model. So let us get started here with the setup briefly. Open up your terminal and create a virtual environment or just use your base installation. We're going to need a couple of packages. So either you go and say pip or pip3 install with your system installation, or you create a virtual environment, or in my case, I'm going to use UV. So UV init to create a UV project, and then UV add, and we're going to add Google, GenAI, we're going to add Pydantic, we're going to add python-.env to load the API key, and we're also going to load pymu PDF2, I think, is the package that we need here. Or is it just pymu PDF? Yeah. That is what we're going to use to plot the actual box in the PDF. Now, what you're also going to need is an API key from Google AI Studio. You can also use Vertex AI. I have a tutorial on this channel where I show you how you can use the Gemini models on Vertex AI if you want to go with that approach. You can also go with the free approach. You just go to aistudio.google.com/app/API-keys, or you just click on API keys here, and then you just click on the API key, or you create one, and then you have it. You just store it in a file. So how you have to do this is you have to go into your development directory, you open up a new file, you call this file .env, and in here you can call the key whatever you want, Gemini _API _key, for example, and then you're going to say equal and whatever the key is. So just enter your key here, save the file, and close it. Now in my case, I have already done this, so I'm going to go into the main py file. I'm going to delete the code here. We're going to start from scratch, and we're going to start by just doing the basic structured output approach that we have when we work with Gemini. So I'm going to say here import OS, so I can load the environment variable. Then I'm going to say from .env import load.env to load the environment variables or the API key from the .env file. Then I'm also going to say from Google import GenAI, and probably I have to, or actually no, it automatically picked the correct environment already, so that's fine. Let's go with this one. So use GenAI from Google, load.env from .env. Then also we want to say from Pydantic import base model and field. Okay, seems like I had to restart VS Code for the linting to work, but there you go. Now we have Pydantic and .env also properly imported here and highlighted. So that is the basic structure. We need to load our API key by calling load.env, and then we need to create an instance of the client. So we can say here client is equal to GenAI.client, and we just have to provide the API key, which in our case is going to be os.getEnv, and the environment key or the environment variable name is whatever you called it in the .env file. So in my case, Gemini API key. That is now an authorized client. We can use it to do prompting with Gemini models. And what we can do now is we can do basic structured output. How does structured output work? For those of you who have never used it before, you basically define classes, Pydantic classes, and you specify fields. So for example, I could say invoice model, and then I can make it inherit from base model. And then I can provide the information that I want the model to extract from the PDF document. For example, I could say total. And I can also say that total is a specific data type. I can say total is of type float, for example, And it's a field. I can say field ... and then description to provide some information for the model. What is the total? I could say the final total amount of the invoice, for example. And then I can continue to do that with other fields. I can say recipient has type string, and this is now the recipient of the invoice, whatever. If there's some more information you need to provide, you can do that here in the description field. Now that is basic structured output. How do we use that? We then just go ahead, we provide a PDF document, and we specify this is a response schema. So we can say PDF is equal to client files upload, and we can say file is equal to our invoice.pdf file. Very simple. Now we can use that as a piece of content, and I can say response is equal to client.models.generate content, and we need to provide a prompt. Maybe we want to specify this here as a multi-line string. And in my case, I'm going to use this one here, extract the invoice recipient name and invoice total, return only JSON that matches the provided schema. Very simple. You can also just say return the invoice data or extract the invoice data, and then it's going to know what the data is depending on the base model here. We can also remove the second total field. But now in generate content, we just have to pass this prompt, and we also have to specify that our model is the response schema. So for contents here, we can say the contents are the PDF document and our prompt. So PDF prompt. Before that, probably you also want to decide on a model to use. This is now not the response model, but the actual AI model. So for example, Gemini 2.5 Flash. You can also go with 3 if you want to. And then the important thing now is the config, which contains the response schema and the response MIME type. So we're going to say config is equal to a dictionary. The first key is the response underscore MIME underscore type. In our case, that is going to be a JSON object. So we're going to say application/JSON. And the second thing now is the response underscore schema. And that is going to be our base model from Pydantic, so invoice model. Then finally, what we're going to do is we're going to say the invoice is going to be equal to invoice model dot model validate JSON. And we're going to pass here the response dot text as input. And then we can just print invoice dot model dump. That is now just basic structured output. We don't have any bounding boxes yet. I'm going to show you the difference here in a second. But if I run this, provided that I didn't make any mistakes, that should give me the total and the recipient without any coordinates, without any bounding boxes. So we get the total and we get the recipient. This is correct information. Now, how can we do this in a more advanced way? How can we actually get the bounding boxes into the PDF document? Quite simple. We can say for each field, I also want to know the location of the information. Now, you can structure this in many different ways. My favorite way is to just have a parent class here called bounding box fields, because we're going to reuse the same kind of fields over and over again. But I'm going to say here that the bounding box field is one parent model class, so one parent class for the model, and it's going to contain 2 pieces of information. The first one is the bounding box itself, which is a list of integers, because a bounding box, we can specify this here in the fields. What the bounding box is going to contain is the coordinates of the corners. So we're going to say here description is equal to, and to not waste your time, I'm going to copy paste this here, the bounding box where the information was found, xmin, ymin, xmax, ymax. So what this basically means is we're going to have the upper left corner, the x coordinate of that, the y coordinate of that, and then we're going to have the bottom right corner, then the x coordinate of that, the y coordinate of that. That is the information that we need to plot a box. 4 points, or actually 2 points specified by 4 coordinates to give us the location of the information. In addition to that, we can have a multi-page PDF. And then, of course, the coordinates are not unique, so we don't know which page we're targeting. For that reason, we're going to say page is the integer, and that is going to be the following description. Let's say the page number where the information was found. All right, so that is now the parent class, and the invoice model will still contain total and recipient, but these are now going to be classes of themselves. So we're going to say class total field, and that is now not going to inherit from base model. It's going to inherit from bounding box field, because this total field will have the value, or we could say total value, or total price, whatever you want to call it. This is going to be a float, and we're going to say that that is going to just be the total of the invoice, the total amount of the invoice. But now it also has, in addition to that, the bounding box and the page, because we're inheriting from bounding box field. Same thing can be done with the recipient. I can just copy this, I can paste this, I can say recipient field. Now this, of course, is going to be a string, and we're going to call this recipient name, and we're going to say, of course, the description, the name of the recipient. But this is now also a bounding box field. And instead of now providing these two fields here, we can just say, I want to have a total, which is going to be a total field. And I want to have a recipient name or recipient. And that is going to be a recipient field. That is the basic idea. Now we can still specify this as a field, so you can still provide a description here, but we're going to leave it like this. And now what our model is going to do is it's going to also extract the coordinates when I run this. So as you can see now, we get total, and total has a certain bounding box. It has page 1, and it has the total value. The value is still correct. Recipient, same idea. We have beta industries, but we also have coordinates. Now, these coordinates don't just appear in the PDF document. We need to actually draw them into the PDF document, which is the second part of this code sample. So to keep it simple here, of course, in a production environment, you would do this with a loop or something, but now we're just going to create a list with items to draw, and these are going to be triples. So it's going to be a list of triples, and it's going to be a string. The first one is going to be total. And what do we need here? We need, of course, the bounding box and the page. So from the invoice object, we want to get the total. From the total, we want to get the bounding box, and then also invoice total page. And then the second object in this list will be not the total, but the recipient, all in caps lock, recipient. And then bounding box actually can stay the same. And then here, not invoice, invoice recipient page. So that is now just a list that we can iterate over. Imagine you have 50 fields here or something. And then what we can do is we can say for label box page in items to draw. First of all, we need to check if this actually exists, if the box actually exists. And for that, we maybe want to add an additional instruction to the prompt here, which is if a field is missing, set it to null and bounding box to 0, 0, 0, 0. That is important because then we can check down here if the bounding box is actually 0, 0, 0, 0. So we can say here, if not box or box is equal to 0, 0, 0, 0, then we're going to just continue. We're going to skip this particular instance here. Otherwise, we're going to draw this rectangle. Now, before we can draw anything, of course, we need to first open the PDF document. For this, I'm going to say document is equal to, and now we're going to use a library that we don't have imported yet, which is fits. And that's actually PyMu-PDF. So you just say import fits. I hope this is how it's pronounced, but that is what we installed when we installed PyMu-PDF. So yeah, a bit confusing in terms of the naming, but that is how it works. So now we can say document is equal to fits.open and then the name, which is invoice PDF. And now we can say the page that we need to draw on is document, and we can just use an index here. Now the page number starts at 1, but of course in a document we need to use index 0. So we always need to say page number, or actually I should say page number here, and then page number here, -1. So if it's page 1, it's going to be page index 0. That is obviously how we need to do this with a list here. Now the coordinates for the bounding box, x0, y0, x1, and y1 are going to be just a box. And now what's relevant is something that I copied here from the documentation. This is just some text. It says in the Google documentation for Gemini, from Gemini 2.0 onwards, models are further trained to detect objects in an image and get their bounding box coordinates. This is what we're using here. So that's not the important piece of information. The important piece is the next sentence. It says here the coordinates relative to image dimensions scale to 0 and 1000. So the coordinates are basically normalized between 0 and 1000, which means we need to rescale them, or they say here you need to descale these coordinates based on your original image size. So we need to do some calculations here to make this work. I'm going to leave the comment here. What we need to do is, first of all, we need to get the rectangle of the page. So I'm going to say here r is equal to page.rect. And then we need to calculate the coordinates with respect to the dimensions of this particular rectangle or page. So what I'm going to say here is I'm going to say the rectangle we want to draw is a fits.rectangle, or just rect. And the coordinates now are the following. We take the dimension, we divide it by 1000 since we have this normalization here, and then we multiply it by the dimension of the rectangle of the page. So what I do here is x0 divided by 1000, but that thing multiplied by r dot width. Then I can copy that, do the same thing with y, but this time with the height. And then we can copy it one more time, the whole thing, and just say x1 and y1. That is now the proper bounding box that we draw into the PDF document. Now to actually draw it, we need to call the draw function. So we say page.draw rectangle. The color is going to be red, so we provide 100 for RGB, so that is the maximum activation for red and no activation for green and blue. And the width is going to be 2. So that is that. Then also we're going to insert text. The position of the text, we're going to keep it simple, is just rectangle x0, rectangle y0, or actually let's go with y0 minus 2 to have it above the box. And here the same idea, color is going to be red, font size is going to be equal to 6. And actually we're going to, before we do that, we need to provide, of course, what we're inserting here, which is the label. And the label is, of course, total or recipient. So the string here, this is just the text that we're inserting. So we want to have, first of all, the location, then the text, then the color, then the font size. We don't need the comma here. That is basically the idea. We draw the rectangle, we paste the text there, and the final thing we need to do is we need to say doc.save and a new file name. Let's call this invoice annotated.pdf and then doc close. Now, if I didn't make any mistakes, this should work. We should get the bounding boxes, we should draw them, and we should export a document with the bounding boxes in the document. So here you get now invoice annotated PDF, and actually I think I messed up the coordinates. Let me just see. Okay, I actually made a mistake here because what we need to do, since this is the way Gemini does it, we need to first get the y values and then the x values. So we want to do y min, x min, y max, and x max. And then once you have this, you want to, of course, also extract the information in the proper way. So you want to swap yx here, you want to swap yx here. But of course, you still want to pass them in this order here. So x, y, x, y. And the rest stays the same as well. So let me run this again. And now if we open up the annotated PDF document, you can see here that we have the recipient, which is Beta Industries, which is now surrounded by this rectangle recipient. Down here we have total and the price in a rectangle. So that is super accurate, and all we need to do for that is we need to provide fields in our data model. Now let me show you that this also works with multiple pages. Let's go and say that we want to do this on the multi-page PDF. So invoice multi-page.pdf. Down here also invoice multi-page PDF, and down here invoice multi-page annotated PDF. So I can run this again. Remember, this is what it looks like. We have the same information, but on different pages. And that is why we also provide the page. You can see here page 3 and page 1. Now, if I open this annotated document, recipient, Beta Industries, and down here, total is $3,135. That is a minimal example, but you can see that this is super powerful. You can build a data model where you specify all your fields as a separate class, or maybe there's also a more intelligent way to do that. Maybe you want to have one class with different bounding boxes. I don't know what the best way is to do this. Maybe you have to do some trial and error, but this is super powerful because you can not only do document extraction, but you can make it very easy for the human in the loop to see what the model is basing the answer on, so that you can correct mistakes. Because the problem with AI is that 99% of the time it might give you correct information, maybe 95% of the time, but the problem is the remaining percentage that you don't get the correct answer. And in this case, you need to have a human in the loop to confirm the information, because actually the debugging and the checking takes more time than actually doing the work oftentimes. So if you just see, okay, the model says this is the total and it got the information from there, and you can, by the way, do the same thing with annual reports. For example, if you extract information from annual reports, you can see, okay, the balance sheet information, the assets, the liabilities, whatever, all this information comes from a certain point in the document. Maybe you have a whole paragraph that explains some risk that the company is taking. And if you can just see where the information is coming from, you can confirm, you can see that there is no hallucination, and this makes it much more professional and much easier to work with. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, in case you're interested in any services or private tutoring, on my website you will find a tutoring tab and a services tab. There you can see what I have to offer in terms of teaching you one-on-one and also in terms of freelancing, machine learning, web development, Python stuff. You can check it out there and contact me via email or LinkedIn. Besides that, don't forget to subscribe to the channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching, see you in the next video, and bye.